Okay, sounds good. All right, let's go to the board. Let's talk about, we're going to talk about cyclohexane for a little while. And then my plan is to take a little break and talk about acid base, then stereochemistry. Stereochemistry will be interesting. After stereochemistry, it will be substitution reactions, elimination reactions. We will cover alkenes, alkynes, some radical chemistry if we have time. Okay, that's the plan. What day is today? Today is 9th of March. I think pace-wise we are fine. We might be looking, we are running late, but I think some of the latter parts of the discussions won't take so much time. Okay, that's the plan. Hi, Cassandra. Cassandra's camera is on. Hi, Shasid. Who else joined? Nate couldn't already. Okay. Edgar. Okay. All right, let's go to the board. Okay, that's my board. And if there is too much glare, let me know. Okay? I'm trying to be organized today. I'm trying to figure it out so that it's more appropriate. So, okay, yeah. You know what? Let me just write down. This is 128A. I'm just going to take a little time, little space, because this helps me sometimes be confused myself. I don't think there is any word that way, but sometimes I'm confused between the three different sets of files, 128A, 128B, and Chem8. So having that written helps. And today is February 9. Okay, I'm just taking up a little space. So we are still talking about cycloalkanes. You guys already know, so I'm putting it on with a very small font, so don't worry about that. Cycloalkane and specifically cyclohexane. Okay. What I'm going to do, I think the best thing to do would be to split the board into three parts and then go from there. So let's keep this top section for any headings. Okay. So we're going to now split the board into three halves.
Professor, I know it's probably not that too big, but the date kind of helps. It's actually March 9.
What did I write? My wisdom went out with my hair. Thank you. Much appreciated. Sorry. It's not funny, but I find things funny in life all the time. Something is wrong with me. My mother should have taken me to a psychologist. Okay. Yeah. So we're gonna talk about. We already started this discussion on last Thursday. We already saw what happens with. Let's use some models before I confuse everybody. Okay? So when we have, this is a plain cyclohexane, right? Plain cyclohexane. Just a quick reminder: 3 axial bonds, up, axial, 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 axial. Okay, and these are the equatorials: equatorial, 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 down, equatorial, 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 right? So from the top point, the equatorial bond is down. From the down point, the equatorial bond is up. And the axials are pointing up and down, perfectly parallel. And that's how we draw the molecule. Okay, so we talked about that. Then we talked about the fact that when you have a monosubstituted cyclohexane, such as methyl cyclohexane, chlorocyclohexane, you can throw in whatever you want. Hydroxycyclohexane, ethyl cyclohexane, isopropyl cyclohexane, whatever. Okay. Then we learned that this is better than this. Then we learned that this is better than that. Axial is no good. Equatorial is better. The problem is it has 1,3 diaxial interaction. You need to remember that phrase, 1,3 diaxial interaction. Okay, why is it 1,3? 1, 2, 3 carbon. So there is a methyl group on carbon 1. Just call it carbon 1 because we are trying to find the relative location of the two groups. 1, 2, 3 or 1, 2, 3. That's why we call it 1, 3 hyphen diaxial because they're both axial interaction. Okay. So if the two diaxial things are let's do this. If the blue sticks represent hydrogens, then this is a methyl group. Yeah. All right. So you can see that I'm just trying to make sure that you can see it properly. Okay. So this is what the diaxial interaction is. When you have a large methyl group and the methyl group is spinning around and they're interacting, they're just way too close from the hydrogens. So this is a methyl hydrogen interaction. So just imagine if you had, I'm just trying to give you a perception of size. Okay, let me build another methyl group and then you will know what I'm talking about. I'm going to put another methyl group here. Okay, this is there are two methyl groups axial. This is also 1,3 diaxial interaction. But imagine the situation, this is really bad. They're literally bumping into each other. They're rubbing each other in the wrong way. Okay, so this is terrible. So as you can appreciate, as the size grows, okay, the chance of having them axial is 0, almost significantly less. So if I flip it, okay, if I flip it, this is much better. If I flip it, they're both equatorial. This is significantly better than that previous situation. This is horrible, as you can tell. This is horrible, horrible. This is worse than having an interaction between hydrogen and a methyl group. There are two methyl groups. So you get the point, right? So generally speaking, the large groups, other than hydrogens, they prefer equatorial positions. That's the bottom line. And now we are checking what happens when you have multiple groups. Make sense? Any questions so far? This is just a quick review. Okay. From now onwards, I'm not going to use the hydrogens on the methyl groups. I'm just going to represent the methyl groups as a black stick. Okay. We're going to first check out 1, 2 on that column, then 1, 3, 1, 3, and then 1, 4. I think this might be not the right separation. Might be no. Okay. So the first molecule that we're going to be checking out is cyclohexane with 2 methyl groups at 1 and 2. Let's do that. Okay. How would you call it? We will talk about the nomenclature in a second. This is going to be 1, 3, and this is going to be 1, 4. Okay. Let's name them. My favorite topic in organic chemistry. Sarcasm. Let's practice. I know it's pretty straightforward, but let's practice it anyway. How would you name this guy Don't worry about equatorial, axial, up, down, anything like that. Just how do you name it? Help me. Somebody speak up, please.
1,2-dimethyl cyclohexane.
And this is Cassandra. Thank you, Cassandra. One, you said 1, 2, and I wrote 1, 3. Sorry. 1,2-dimethyl cyclohexane. Perfect, Cassandra. 4 out of 4. Somebody else name this molecule. Speak up, please.
1,3-dimethyl.
I appreciate the effort. Dimethyl cyclohexane. Okay, this one is understood. 1,4-dimethyl cyclohexane. I'm not caring so much about my handwriting or keeping the font up because I think you know what I'm writing. Dimethyl cyclohexane 1, 2, 1, 3, 1, 4. Okay. Now we already did this experiment. Okay. When we draw the molecule, yeah, let's draw it here. I'm going to just flip it. We flipping the molecule, okay? And the first molecule that I'm going to draw, I have options, right? I can, let's say this is 1, 1. Let's say this is 1, 2, 3, 4, 5, 6. 1 and 4 are on the whiteboard. 2 and 3 are popping out. 5 and 6 are behind the whiteboard. After I flip it, 1 becomes that. That's also on the whiteboard. The corner, and that corner is on the whiteboard. So that corner has popped down. 1, 2, 3, 4, 5, 6. Okay. So methyl groups, let's say really pay good attention right now because this is going to be your asset, organic chemistry knowledge asset for the rest of this class as well as for the next class. This is going to be important. You will need this, okay, this concept. It'll also make our journey through the stereochemistry chapter smoother because that's when things can really become a source of headache and you might be feeling busy and unstable sometimes. I'm joking, but then stereochemistry is a lot of imagination, a lot of geometric shapes, a lot of imagining like the mirror image and looking at the molecule from top, bottom, side. So this practice is going to be very helpful. Okay. All right. So we numbered it. There are 3 sets of cyclohexanes. Both have 2 methyl groups. Next door neighbors, 1 house away, farthest away from each other. Got it? All right. So for this dude, for this molecule A, okay, I want you to put the methyl groups in the most comfortable positions. Okay. 1 and 2, I have 2 options. Option 1, equatorial. Option 2, axial. I'm going to erase the other one. Up and then carbon 2, I have 2 options. Equatorial or axial. Okay, where shall I put the methyl groups if I tell you that they are supposed to be the most energy efficient molecule, lowest energy molecule? Where shall I put the methyls? Axial, axial, equatorial, equatorial, axial, equatorial. What do you think? Which one is the best? We have gone through this exercise on last Thursday.
Both equatorial.
Both equatorial. Very good. Thank you. I'm going to erase the rest. Okay. a little piece of information. Make sure you can draw cyclohexane chair properly and put the groups properly. Okay, and so this is flipping. This is flipping to that. So after it flips, I would strongly recommend right now that you take notes. You have a piece of paper, scratch paper. Don't write on the wall if it is your parents' house. They're probably going to kick you out. Write on a piece of paper and do exactly what I'm doing right now. Okay? This bond is parallel to this bond. 5, 6, and 3, 2 bonds. Okay, and this is the same way. This methyl group is parallel to 1, 6, and 3, 4 bonds. That and that, like a Z. Okay. After I flip, carbon 1 should be holding on to the methyl group here. Should it be, how should I draw it? Is it going to be, okay, let's say this is equatorial. Equatorial, this is the best. We already know this is the best. Okay. What happens after I flip it? The methyl groups become what? Equatorial becomes?
Axial.
Axial. So how do I draw it? On carbon 1, I just draw it down. That's my methyl group number 1. Methyl group number 2, which is on carbon 2, how do I draw it? Very easy. Sorry, axial. They're both axial. So I'm going to draw the axial with a red A. Okay. And because they're both axial, they're both suffering from 1,3 axial interactions, diaxial interactions, with 1 hydrogen here and 1 hydrogen here. So this methyl group, the CH3, is bumping into this guy and this guy. And this methyl group, with the 3 hydrogens, it's bumping into from the hydrogen from the number 5 carbon and number 3 carbon. So there are actually altogether 4 1,3 diaxial interactions. Pretty bad. That's probably going to be the worst. Okay, this is probably the worst. This is the best. All right. So this is 1,2 diaxial di-substituted cyclohexane. We just put methyl groups. Okay, that's one scenario. Scenario number 2, I'm going to split the board. Let's put some lines. That's just the molecule in 2D. Just the molecule in 2D. Just the molecule in 2D. And that's our, I went outside my line. Sorry about that. This is our best. That's probably the worst. We will see. That's A. Let's say this is B. Okay. That's how our camera goes, approximately. Okay, that's A, and this is B. Okay. Now let me split the board again. Now let's try. So these are both equatorial. Now let's try axial. You know what? I'm going to keep a little space here for some discussion. I just remembered. Little more space, maybe. Okay. We might have some discussions here. Okay. So the next set, 1, 2, under 1, 2. Again, it's going to flip. Okay. And the numbering is going to be 1, 2, 3, 4, 5, 6. 1 has come down. 1, 2, 3, 4, 5, 6. Okay. Now what we want to do is make them equatorial axial. Okay. Half and half, not both equatorial. Let's put this guy equatorial. Let's put this guy axial. Okay. So let's say this is equatorial and this is axial. Okay, makes sense? After you flip it, what happens? Well, number 1, the number 1 guy who was equatorial, now has become axial. Number 2, methyl group on carbon number 2 was axial, now equatorial. Let me label them. Make sense? Before we go to 1,3 and 1,4, here and here, let's make models and talk about how can we describe the relative orientation of the methyl groups. Pay attention, really pay attention. Don't be distracted. Don't watch any YouTube video right now. Okay. Let's make this model. Sorry. So this is A, B, C, D. 4 of them. Okay. So this is A. Are you guys okay that this is representing molecule A? Equatorial, equatorial. Okay. I'm going to introduce a concept that you may have seen in double bonded compounds. When you have a double bond, excuse me, and when we have the large groups on the same side across a double bond, I'm just going to temporarily draw here. This is on the side. Side discussion. I'm going to erase it. I'm not going to keep it for a long time. When you have a double bond, and if you have 2 methyl groups on the same side versus 2 methyl groups on the opposite sides, does anybody remember from your past, I think in general chemistry you may have been exposed to it, when the large groups are on the same side, there's a name for it, it's a C word. When the large groups are on the opposite side, there's a name for it, it's a T word. Do you know what I'm talking about?
Is it the cis trans?
Exactly. So which one is which? Is this cis or trans?
Cis.
Awesome. And this is trans. Okay. So cis is same side and trans is opposite side. This is just a temporary discussion. I'm going to erase it. Thank you. And this is Edgar. Good job. Okay. Pay attention because the book doesn't do a good job. Actually, all the books I've seen does do a pretty bad job. You can call me that I have some attitude here. Yeah, I do have attitude because sometimes I feel like writing a textbook in my way. Okay. Really pay attention. So this dude, equatorial, 1, 2, equatorial. Okay. Doesn't it look like they're on the same side? They look pretty close. If you have to label it as cis or trans, how would you label it? What's your gut feeling? Would you call this guy cis or would you call this guy trans? Let me so imagine that this is a hydrogen. Imagine this is a hydrogen. I don't think I have enough other groups. No, I don't think I have. All I can do is I can stick this guy here. My models have been stolen temporarily. Okay. So that's a methyl group, that's a methyl group, that's a hydrogen, that's a hydrogen. Okay. If I could draw it, this is why I wanted to keep some space. If I drew this molecule in 2D, and I wanted to tell the audience that this is cis or trans, and the groups are either sticking up or their groups are sticking down, how would I determine that? How would I represent this molecule? Something like this with the methyl groups as wedge or dashed line. Okay. If you look at this molecule and imagine this is the chair form, this is the good way to look at it. This is the fancy way of looking at it, to 1,2-dimethyl cyclohexane. But if you look from the top, okay, what's sticking up on carbon 1 is the methyl group down or the methyl group up? That's the hydrogen. Is the methyl group down or up? I can't hear you, Georgiana.
Isn't it down?
It's down, right? So let's do it. Let's do it the right way. You may have no other choice but buying a model right now, unless you are really good at seeing things this way. Okay. So now, if I'm trying to draw this molecule A, and let's say this is the numbering, I'm going to just rotate the molecule a little bit. 1, 2, 3, 4, 5, 6. So if I have a choice to draw the methyl group down with a dashed line or up with a wedge, should it be a dashed line or a wedge or number 1 carbon? What do you think? Try to engage in the thinking process, please. Should this be a wedge or should this be a dashed line? Which one?
Dash.
Dash lines is going to be in the background.
Does everybody who is listening to the Zoom talk get it? Looking at the model. Now looking at the model, comparing with the hydrogen that's axial, this equatorial methyl group is down. From our perception, the way we are looking at the molecule, we are not looking down this way. Then it's up. If you're looking at it from this angle, okay, if you're looking at it with this angle, carbon 1, 2, 3, 4, 5, 6, 1 and 4 are on the whiteboard, 2 and 3 are out, and 5 and 6 are behind. With that perception, looking at the molecule slightly from the top, this is down, not up. Does everybody agree with me?
Yeah.
Yes.
We are done with the carbon number 1, methyl number 1. Methyl number 2, which is on carbon number 2, is this, from this perception, is it up or down? Should I draw it with a wedge or should I draw it with a dashed line?
You should draw it as a wedge because it's going upwards.
Let's do this one. After we flipped it, let's check it out. Here is the molecule, right? Here is the molecule. Carbon 1, 2, 3, 4, 5, 6, down and up, dashed line and wedge. Let's flip it. After we flipped it, carbon 1, 2, 3, 4, 5, 6. The methyl group on carbon 1 is still down. Methyl group on carbon 2 is still up, but they look different. They're both axial, but this is down and this is up. So nothing has changed with that relative orientation. Make sense? Carbon number 1, methyl group is down. Carbon number 2, methyl group is up. If I flip it, it doesn't matter. It's still down and it's still up. This is a concept that took me many years, more than a decade, to basically really figure out how to teach. Because when I learned it as an undergraduate student, I had no idea what was going on. Okay, I had real hard time seeing through. But if you take the model And if you see what's up and what's down, it's clean like a sunny morning. Okay, there's high visibility, 50 miles visibility. Down and up, still down and up. Because this is how the molecule is born. You're not swapping the groups. Okay, all you're doing is you're flipping. Watch that end when I flip. It's still up and it's still down. Okay, we're done with that. So if I draw one group up and one group down, they're not on the same side, right? If I draw it that way, should I call 1, 2 equatorial or 1, 2 axial? Should I call it cis or should I call it trans? If I drew this molecule, cis molecule, and if there was a way I could draw it with a wedge, shouldn't I draw the molecule with the methyl groups? Well, maybe we can swap it, switch it. Methyl groups down, and they're kind of out. They're kind of back, and this molecule will be drawn as hydrogen. This is a hydrogen, and this is actually a methyl. Okay, out and in, up and down, up and down. This is both are up, both methyl groups are up. So should we call this set, one is up and one is down? Don't go with your gut feeling. Don't listen to your heart in this case. I always recommend that we follow our heart. In this case, listen to your brain. The analysis. Look at the analytical aspect of the situation. One is down and one is up. Just focus on that. We figured out that one group is down and one group is up. Should it be cis or trans? Just answer that.
Trans.
It is a trans molecule. So 1, 2 whatever substituted cyclohexane, when it's equatorial, it is trans. Even though goes against your perception, it's kind of contradictory to your perception or your gut feeling. Oh, you think, oh, they're looking so close, they're cis. They're cis. No, they're not cis, they're trans. Because of the reason we figured out up, that's up and that's down. This is up and this is down. They happen to be down and up. If they're down and up, they're trans. Okay, next. Equatorial axial. 1, 2 equatorial axial.
1, 3.
If I draw this molecule again in 2D, somebody has something running in the background. Can you just turn it down? I don't know what it is. Okay. 1, 2 dimethyl cyclohexane, and they happen to be equatorial axial. How should I draw the bonds? The bond number 1, this methyl group, should it be wedge or dash line? Is this up?
Dash line.
Dash line, yes. How about the methyl number 2? Is it up or down? Is it wedge or dash line?
Wedge.
Excuse me. Let's see what happens when I flip it. Do you think it's going to change? Probably not. I flipped it, It's still down, and it's still down. Axial happens to be the down, and this equatorial happens to be the down. So it's still the same. So is this cis or is this trans?
Cis.
Is this
Cis.
So 1,2 diaxial, 1,2 dimethyl cyclohexane, when they're equatorial axial or axial equatorial, they're cis. We could have also drawn the same molecule. It doesn't matter. We could have drawn it this way. It's the same thing. You know why? So it's looking, they're both looking down and down, but what if I flip the molecule upside down? They're both up and up. So drawing them both with the wedge or both with the dashed line, it really doesn't make any difference. All you're doing is you're flipping the molecule. Okay. If you have an object, just imagine, I'm going to do like a very silly experiment. I'll take a piece of paper, not even piece of paper, just whatever I have here. I'll take a piece of paper, I'll fold it down, right? So it's looking like it's down. So if I flip it, it looks like it's up, right? So it really doesn't matter. So if this is cis, both edges are down, dashed lines, but what if I look at it upside down? Then both edges are up, right? And if this is trans, up and down, the sides could change. If I turn the molecule upside down, then it's down and up, not up and down. Make sense? You guys are doing okay? Not feeling nauseous or little dizzy? I'm going to erase this part. Let's go to the next one. You need to really think through it and absorb the material. Okay, so now that's 1, 2. Let's go to 1, 3 and let's see what the deal is. We flip it. 1, 3 will be here and here. I don't have the patience to draw all the numbers here and here. Okay, let's draw the best so far. Best one first. Equatorial. You need to. I'm assuming you have already mastered the skill of drawing cyclohexane chair and putting all the groups in the right positions, axial and equatorial. Parallel to this bond. This is parallel to that bond. Okay. So 1, 3 diaxial, when I flip it, we could have drawn it a little bit higher up. We don't have the luxury to draw it. Equatorial. Okay. When I flip it, this is carbon number 1 and 4. That's carbon 1 and 4. Equatorial becomes axial. Equatorial becomes axial. You know what? Let's just number it so that you guys are not confused. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've been writing equatorial with purple and axial with red. Okay. This molecule. Okay. let's call it A, B, C, D. Let's call it E and F, and then we will write the next two. This guy, again, it looks like a little spaceship or some kind of stingray with two fins. Let's say these are the hydrogens. Okay, if I have to draw it in 2D, just to send the message across, this is pretty complicated. If I have to draw this molecule in 2D, and this is carbon 1 and this is carbon 3, shall I draw the methyl group on carbon 1 with a dash or a wedge? This methyl group should be drawn with a wedge or a dash line.
Dash line.
After I flip it, what happens? They're still down. It's the same molecule. So should it be cis or trans? It's actually pretty obvious. Does it look cis on the same side or opposite side?
Same side, cis.
Same side. So this is cis. 1, 3, equatorial is cis. But 1, 2, equatorial was trans. Pay attention, you need to study, because I'm going to be checking on these concepts in the next quiz. 1, 2, equatorial or axial is trans. 1, 3, equatorial or axial is cis. Okay, let's switch to one, 3, equatorial axial. This guy. 1, 3, equatorial. Something is wrong. Sorry. One, 3, equatorial axial. This is equatorial. And let's call it EFGH. So this is equatorial and this is axial. Okay, 1, 3, carbon 1, equatorial methyl, carbon 2, carbon 3 toward you. Number 3 is axial, up. After I flip it, the guy that was axial becomes equatorial. The methyl group that was equatorial becomes axial. So this guy becomes axial. This guy becomes equatorial. You might be really getting dizzy right now because there's a lot going on. It's easy for me because I've been doing it for a long time, more than many decades, like roughly 10 decades. Okay, so axial, equatorial, axial. Now, if I have to draw it again in 2D, let's say that's carbon 1 and that's carbon 2. Carbon 1 Should I draw that methyl group with a wedge or a dashed line?
Dash line.
Should I draw the methyl group on number 3 with a wedge or dashed line? If this is the perception. This is down, and that's up.
Wedge. It's up.
After I flip it, you know the secret, it's not going to change. Down and up. That was a bad way of flipping it. Down and up, still the same. The relative orientation of the two groups haven't changed, but they have gone from equatorial to axial and axial to equatorial. Okay, so if I have to label it cis or trans, should I call this couple cis or trans?
Trans.
Thank you. Next, doesn't end, I'm sorry. I'm going to switch the groups to number 4 carbon. And we'll make the best one first. Okay. We'll put the methyl group equatorial and the hydrogen axial. I screwed up. Let me see. That's right. We're going to call it A, B, C, D, E, F, G, H, I, J, and this is 1, 4. And the methyl groups are at first the best of the bunch, equatorial, equatorial. And after I flip it, both become axial. Might be getting headache. I'll give you guys a minute break after we finish this side. Equatorial, equatorial becomes axial, axial. Okay, without cheating, please don't cheat for your own benefit. Don't look at that and don't think about models. If you have a model, don't use it. Okay, I'm trying to block it. I wish I could block it. What do you guys think? Can you now imagine the molecule looking at the cyclohexane chair? Can you imagine the locations without thinking about the model? I'm going to hide the model here in my desk. Okay, that's equatorial methyl. There's a hydrogen down here. That's equatorial methyl. That's a hydrogen up here. Looking at I, conformation I, does it look to you cis or trans? What do you guys think? Without using the model.
Trans.
Trans.
So there is a hydrogen here. There is a hydrogen here. There is a hydrogen here. Some of you are probably, as I said, it's not that you are more intelligent. You just, that's the way your brain is wired. As I told you that I suck at navigation, but I'm really good at this. Okay. I love geometric shapes. So you can push yourself if you're having trouble seeing it, then I'll hold the model. You are absolutely right. This is trans. If somebody is having a trouble seeing it, and want to admit it and want to learn from the model that why should it be trans, can you just identify yourself? Like, I'm having trouble. I think identification of shortcomings is also important. Like, I don't know this. Many times we don't know to say that we don't know. You know, we have too much ego or fear. Don't be afraid, please. Anybody having trouble seeing that the methyl groups are, one is up and one is down, or everybody is getting it? So if I throw a quiz, a pop quiz with 2 bonus points on Thursday, will you all get it without cheating? Is everyone okay with this concept? I haven't showed the model yet. Anyone wants to see the model? Why this is trans? Or you're okay with it? This is pretty detailed. This is a pretty complex concept. If you get it, it's not complex, it's easy. But if you somehow get tangled in this web and you're having nightmares visualizing it, then it's difficult. Anybody wants to say anything about it, or any questions or any concerns? Shall I assume silence means positive? You guys got it? Let me show you the model anyway. This is 1,4-dimethyl, both equatorial. What are my choices? Up or down? This is definitely down. This is down or up? This is up. So this combination is down, up. So that's dashed line, that's wedge. So if I have to draw it I'm just going to draw one of them. If I have to draw it, that guy is down. This guy is up. Okay. Last. So this is trans. Last one, pretty straightforward. This is equatorial, axial. We're going to swap them. You know the answer because it's going to be the opposite. It's not a secret. Equatorial, axial. Okay. Equatorial, and axial. What are my choices? How does the hydrogen fit here? Well, the hydrogen is here and the hydrogen is here. After I flip it, this guy becomes axial and this guy becomes equatorial. And the hydrogen is still here and that hydrogen is up here. And the combination is axial, equatorial. And the next question, as you know, what I'm going to say is draw the molecule in 2D so that anybody can understand what's going on. And let's say this is 1 and this is 4. Okay. Shall I draw the methyl group on carbon 1 here with a dashed line or wedge?
Dash line.
How about the one on carbon 4? Up or down, dash or wedge? Anyone, please? This methyl group, wedge or dash? Speak up, please. Come on, I don't have all the time to wait for your answer. What's the dilemma?
Wedge.
Thank you, John. So this is trans. I'm going to take a picture. I'll give you guys a minute to kind of ponder and get it in your system. Don't lose it. There is a lot of information. I don't know how the book does it. I don't read the book much unless I have to really verify some concept that I got to, rusty or sketchy. 1, 2 die substitution, 1, 3 die substitution, and 1, 4 die substitution. Cyclohexane, the bottom line is this exercise is important because there are many compounds that have the cyclohexane form in it. Okay, and you could have groups like you can have a chlorine here and a bromine here, and the two chlorines can be both equatorial or equatorial and axial. Okay, and depending upon that, the molecule might interact with the protein or the enzyme as part its drug action differently. So equatorial will probably behave in a certain way, and equatorial axial will behave in a completely different way. They're completely different molecules. That's why this is a perfect discussion before we get into stereochemistry. Stereochemistry is all about left molecule and right molecule. Have a molecule have its mirror image. Are the mirror image and the real molecule same, or they're different? Okay, we'll talk about that. So 1, 2, 1, 3, 1, 4. All the 4 different ways or 3 different ways to put the molecules together, both in the most comfortable position, and when it flips, it becomes the bad conformation. So if you have this guy, and if in air, let's say 1,2-dimethyl cyclohexane is floating around in air, it's probably going to flip a little bit, but mostly the molecule will be liking this conformation because we all know this is a bad conformation. Between this guy, equatorial axial and axial equatorial, you guys can think about it. You guys can start pondering about it. Are they really different or the same molecule? We'll practice that. That's when stereochemistry comes in. Anybody wants to take a call? The EA, 1E, 2A, and 1A, 2E, are they identical compounds? They're identical compounds, right? Because we just flipped it. If we flip it, it's the same molecule. But we will get into the deeper discussion. I promise we will start our stereochemistry discussion with this disubstituted cyclohexanes. It's pretty cool. That's that. And we found out that even though the equatorial looks like it's the cis, it's opposite to your instinct. You might think that, yeah, that's cis, man, look, that they're so close. They're not cis, not for the convention. The convention is this, are they both down or both up? Well, hydrogen is up, this is down, so it's down. This is, hydrogen is down, methyl is up, so it's up. So dash and wedge. Dash and wedge means they're on the opposite side. That means they're trans. So 1, 2 EE is trans, 1, 3 EE is cis, 1, 4 EE is trans. Okay? They kind of rotate, skip a generation. It makes no sense. Ignore that. 1, 2 EA is cis, 1, 2 EA is trans, 1, 4 EA is again, oops, I did a boo-boo.
Yeah, shouldn't the last one be cis because the A is going down? I was like looking at it and I was like, that cannot be trans. Like, has to be cis. Like, what's going on?
You have interrupted me. Interrupt me. I will really like you guys more if you interrupt me for the right reason.
All right.
Thank you. No, I thank you. I appreciate that. Yeah, this is that's just a typo.
The reason why I then corrected you because your model was showing something else, and I thought you were going off the model. I was like, what? Because the model
No,
showed
and that was not. That was also not like a trick thing. You know, sometimes I'll deliberately put something wrong. No, that was a genuine mistake. Yeah, that's cis. So 1, 2, EE trans, 1, 2, EE cis, 1, 4, EE trans. So trans, cis, trans. 1, 2, AE cis, 1, 3 trans, 1, 4 cis. You can literally see that they're both pointing down. Okay. And it doesn't matter how you draw it. Again, you could draw the molecule in a slightly different way. You can draw it this side up and that side down. It really doesn't matter. Well, we will expand on that discussion when we talk about stereochemistry. Where are we? 131. I'm going to replace the previous picture. Hold on.
Before you take a picture, it needs to be dashed instead of the plot for the last one.
Yep, I'm just deleting the previous picture. I'm going to take a sneak. Thank you. Appreciate it. Okay, sorry, I'm blocking the camera again. Any questions? My wall clock just lost its battery, so I need to replace that and keep an eye on the clock. I have another appointment at 1:45. 1, 2, 1, 3, 1, 4. You guys need to study this. If you don't do it, you're going to really bomb the next quiz. I'm actually thinking about putting some multiple choice questions in the test number 2, but I'm going to make the quiz totally free response. Okay, I'm not going to make it what do you call multiple choice. Okay, everybody is good. So now let's practice a few molecules. Okay, let's practice a few things. I don't really know what else I'm going to talk about as far as cyclohexanes are concerned. So I might go a little easy today because I always take like a little extra time.
Professor, before you completely erase that last part, the 1,4 cis section, the 2D model shows trans, doesn't it? Because it's a wedge and a...
Thank you. Yes, Cassandra. Why didn't you tell me 2 minutes ago?
I tried telling you that, but you said, yeah, that's why I'm going to delete it. That's what I was mentioning.
Georgiana, I don't know, I can't hear everything that you say.
Yeah. So it's probably bad internet.
It could be bad internet. I'm sorry, I was not ignoring you. Okay.
Oh,
Yeah.
that's fine.
Okay, everybody, I screwed up, correct it. So it's don't be afraid to correct me. Please, please, please. When you interrupt, it really brightens my teaching. It motivates me more. That means you guys are paying attention. So I can't go back and fix that. I can't do like funny business with that still picture. I can actually try. Yeah, before actually the video is messed up. So make sure that when you're watching the video, it's supposed to be down, down or up, up. That's my bad. Okay. Thank you, both Cassandra and Georgiana. Appreciate it. Sorry, Georgiana, I was not ignoring you. Let's blame it on technology, okay? I feel now terrible that you were just correcting me, and then I was like, yeah, and I just didn't do anything about it. Yeah, because I should have told you that I can follow you. Yeah, I'm not perfect. I'm pretty messed up actually. An auto mechanic just told me that I should go see a psychiatrist. Okay, no more jokes, bad jokes. The auto mechanic is my friend. He specializes in some kind of cars. He's in Pasadena. I'm going to go see him, but I don't have the money to do the work that I'm planning to do. So he was like, come on, man, make up your mind. What's your problem? Okay, where I have no idea. I don't think I should be looking at that clock because it's pretty wrong. This is our line of control. That's the best wiggly line I've ever drawn in my life. 136. Okay, let's do a few practice problems. You might be wondering, like, what is he going to ask from this crazy discussion that we just had today? Well, this is what I might ask. If I say cis 1,2 diethyl cyclohexane. Got it? Cis 1,2 diethyl cyclohexane. Got it? If I say draw this, draw it in chair form. How would you pull it off? You really need to know what's going on. And if this is a free response question, if you cheat and if your question answers look the same, then you're in trouble. You are in trouble if you don't know how to do it. Draw chair. 1, 2. Figure out where 1 and 2 are. Okay, that's where your 1 and 2. Diethyl. So in 2D, it's going to look like it's cis, right? So it's going to look either this way or this way. Sorry, either this way or it doesn't matter. You understand that both represent the same thing, right? Everybody understands that. Down, down, or up, up doesn't make any difference. You can flip the molecule upside down. How do we draw it here? Let's make a little more room. This is 1 and 2. That's 1 and 2. That's 1 and 2. Let's follow this guy. Okay, I have two choices to put the ethyl group here. My suggestion is, if I ask you to do this, first draw the 2D version, flat version of it with the wedge and the dashed lines. Do that first. Then you transpose it, then you convert it into a chair. This is probably safer. Don't just jump to the answer this way unless you're really comfortable. Okay. Shall I put the number 1 ethyl group at axial or equatorial? I have two choices. Here or here. And the second guy, here or here. Where should we put the first one? Equatorial or axial?
Equatorial.
And this is Anna Marie. Thank you, Anna Marie. You said equatorial, right? Somebody else who hasn't spoken today. Second ethyl group, should it be equatorial or axial?
Axial.
Who is this? Same guy, Edgar. Thank you, Edgar. Doesn't it look like a frog? Correct. Perfect. Let's try another one, then I'll let you guys go. Let's draw trans 1,4 I don't know, throw something, dichloro cyclohexane. Okay, in chair form. Okay, let's draw the 2D stuff. Okay, that's easy. Trans 1,4 dichlorocyclohexane. Pick any cross points. 1, 2, 3, 4. 1, 2, 3, 4. Let's go 1, 2, 3, 4. Okay, this is a flat. This is the 2D. Should I draw If I draw one up, it's a chlorine. Should the second one be down or up? It's trans. Dash or wedge? Quick. It's a trans. It's on the opposite side. So this chlorine is up. This chlorine should be down or up?
Down.
Thank you. Now let's convert it into a chair. Let's say 1, 2, 3, 4. If this chlorine is up, should this chlorine be drawn as axial or equatorial? Carbon 1 chlorine, should it be axial or equatorial?
Axle.
This chlorine is down. Should it be axial or equatorial on carbon 4?
Equatorial.
Think.
Either both axial or both equatorial.
Okay, so let's get one thing at a time.
Axial.
Let's get this one done. Does it look, if I didn't specify that, draw the more stable conformation. If I didn't specify it, this is good, you get 4 out of 4. But if I specified that draw the most stable conformation of this guy in using chair, then you will get penalized. I don't know, maybe you will get 2 out of 4 or 1 out of 4, depending upon how you have done. Then it's wrong. Then what should we do? We should flip it, or as you said, we should put it, you don't even have to flip it. This is axial, axial. Up and down. Okay. In order to make them equatorial, equatorial, you can put it here, right? Then it's down. So you can, why don't you choose the next carbon? That's the trick that I'm teaching you. Let's put red color for chlorine. Not that chlorine gas is red, then at least it kind of stands out. Okay, if I use the same way I've drawn that cyclohexane chair, I can't make it equatorial. But what if I pick this one? If I rotate the molecule, 1, 2, 3, 4. Okay, now the up position is this one. That's equatorial. And 4, the up position is, the trans is, this is the down, up and down. So this is still up chlorine and down chlorine. I just taught you something like you can draw the same thing, or you could have drawn it in this way. We have drawn the other cyclohexane chair and make it look like chlorine here and chlorine here, up and down. That's the same thing. These two are pretty much the same. I think that's good enough for today. There was a lot of information that went toward your direction like a snowstorm. Please, please, please
That dog got out.
pay attention. Please study.
Or whatever his name is. Yeah.
Okay. I'll see you guys on Thursday. Please study. I'll make this available as soon as I can. Okay, have a good day. I don't have much time right now.